Hello, in today's lesson, we're going to talk about ratios in similar polygons. The essential questions are, how do you identify similar polygons, and how do you apply properties of similar polygons to solve problems? Similar figures are figures that have the same shape, but not necessarily the same size. When checking if polygons are similar polygons, there's two criteria that they have to meet. Their corresponding angles have to be congruent, so the exact same measures, and their corresponding side lengths have to be proportional. Remember that proportional just means that they're in the same ratio. All right, so let's look at an example of a set of similar polygons. This diagram here shows triangle ABC and triangle DEF, and these triangles are similar because it meets both criteria. So let's start by filling in the similarity statements. Angle A is similar to congruent to angle D. Notice how A and D each have the one arc. And then angle B is congruent to angle E. That each has the two arcs in the picture, and angle C is congruent to angle F with the three arcs. Okay, so corresponding angles are congruent. That is true. And now for corresponding sides, you want to match up like parts with like parts. So AB matches with DE. So the ratio of AB to DE is 6:3. And then if we simplify our fraction by dividing by 3, we get 2/1. Let's check the next ratio. The ratio of BC over EF is 9 divided by 4.5. And if we divide that out, divide by 4.5, you also get 2, or 2/1. So they're the same ratio, that's proportional. And now for our final one, let's check CA, which is this 10, and DF, which is the 5. Well, 10/5 also reduces to 2/1. So that's what it means when the corresponding sides are proportional. All of these values, when you simplify them, have to be the same. Now, when you write what's called a similarity statement, you just need to line up like parts. So if I name the first triangle, triangle ABC, I have to say is similar to, and the symbol for similar is a little squiggle like that. And then when I name the next triangle, I have to go in the same order. So ABC matches with DEF. That way angle A and angle D are in the same spot. Angle B and angle E are in the same spot. And angle C and angle F are in the same spot in the statement. So you have to write it so that corresponding parts match up. Now, a couple more vocab words here. A similarity ratio is the ratio of the lengths of the corresponding sides in two similar polygons. So in our example, the similarity ratio from triangle ABC to triangle DEF, the 2 is like the divide sign. So ABC, we have to put that value on top, DEF on the bottom. So if I look at my values there, the similarity ratio is just 2/1. Now, if I switch it to the similarity ratio of triangle DEF to triangle ABC, those just switch around, and now it's 1/2. So all that happens from here to here is you flip the ratio. Now that we have the definition of similar polygons, let's go ahead and identify the pairs of congruent angles and corresponding sides in the similar triangles below. Starting with the angles, you can see that angle Z and angle R are each marked the same. They have the one arc mark. So I'm going to say angle R is congruent to angle Z. And then there's a second set of congruent angles that's marked in the picture. Angle Q and angle Y each have two arc marks. So angle Q is congruent to angle Y, And both of these are just given in the picture. I am, though, missing the last pair of angles. And for the last pair of angles, we know that if two pairs of angles are congruent, the third angles also have to be congruent. So we can conclude that angle S is congruent to angle X, and that's by what's called the third angles theorem. That goes back to a theorem from our triangle chapter earlier in this course. All right, so now I've got the angles established. Let's go ahead and look at the ratios of the sides. So for the side ratios, we have to be like super careful that we match them up correctly. So if I start with like side, for example, QS. See how QS is between the 2 arc mark and the 3 arc mark? I got to go in the same spot on the other triangle, so that's going to match with YX. And when we took the values there, that's 9 over 6. And let's see, so 9 over 6. And if we reduce that, 9 and 6 are both divisible by 3, so 3 over 2. Let's check the next ratios. So next I'm going to look at the 18 side. So this 18 side is between the 2 arcs and the 1 arc mark. So the 18, the side QR, matches with side YZ. And that's going to be 18 over 12. If we reduce our fraction here, if I divide by 6 on each of these, we get 3 over 2. So far we are good. We have matching ratios. We just need to check that last pair of sides. So we'll do side SR. And side SR is between the 3 and the 2 arc mark. So that's SR matches with XZ. And that is 13.5 divided by 9. Now this one I realize is kind of hard to simplify, but if I know I want the bottom to be 2, we have to divide it by 4.5 because 4.5 is half of 9. So there we go. And if you grab your calculator, you divide that out, it is 3 over 2 as well. And this shows that the corresponding sides are proportional. So angles we established up here. So that covers all the angles. And then proportional sides we covered down here. So we can write the similarity ratio. The similarity ratio is just the same as the ratio of the sides. So it's going to be 3 over 2 as well. And then for our similarity statement, we just have to write them so that the like parts match up. So you can actually name the first one however you want. So maybe I want to name the triangle on the left. I'll just go QRS, alphabetical. Now, since Q matches with Y, in my next triangle, I have to start with Y. Now, R matches with Z, so Z has to be our second letter. And then the S matches with the X. So we could say something like triangle QRS is similar to triangle YZX. In this next example, we are going to try to determine whether the polygons are similar. So we're going to check the 2 criteria. Are the angles congruent and are the corresponding sides proportional? Now, first thing to note here, and I know you've studied quadrilaterals before, but rectangles have all 90-degree angles. So in a rectangle, by definition, all 4 angles are 90 degrees. So for kind of criteria number 1, where we look at the angles, corresponding angles are congruent because all angles are right angles. And right angles are congruent to other right angles. So that establishes criteria number 1. Let's check criteria number 2, which is the sides. So for the sides, I have to check, are they proportional? So side PS matches up with side TW. Let's check that ratio, PS over TW. I'm going in the same spot in the statements here, and you can kind of see they're lined up really nice here. So 4 and 6. Well, if we do 4 over 6 and then we divide by 2, the ratio of that is 2/3. Let's check the other side. So we have 12 or PQ. So PQ matches with TU. So PQ over TU. Again, first two letters. So that's 12 and 16. Well, 12 and 16, let's see if we can reduce this here. I know that those two numbers are both divisible by 4. So if we divide that out, we get 3 over 4. Now, these two numbers are not the same. They're not equal. And since they're not equal, the sides are not proportional. Now, even here's how we know they're not equal. 2/3 is like 0.6 repeating, whereas 3 divided by 4 is 0.75. So those numbers are definitely not equal. So that means that these two rectangles are not similar. And the reason they are not similar is because the corresponding sides are not proportional. So if it's not similar, you don't have to write a similarity ratio. There isn't one. And you also don't have to write a similarity statement because they're not similar. So you can just say not similar and then move on to the next one. Okay, let's try one more here. Triangle ABC and triangle DEF. Determine whether they're similar. If so, write a similarity statement. Well, notice that angle A and angle D are already the same. And angle B and angle F are also, B and E are also the same as marked in the picture. So that's kind of given. And then we know that the other pair of angles, angle C and angle F, have to be congruent by the third angles theorem. Okay, so we've established the angles. We're good there. Now let's check out the ratio of the sides. I'm going to start with side AB. Side AB corresponds with side DE. Notice, too, in the picture, they're between the one arc and the two arcs. So let's go AB over DE. And that is equal to 20 over 15. And then if we divide by 5, we can simplify that to 4 over 3. Okay, let's check our next ratio. Next up, I'm going to look at AC. And AC right here, 16 matches up with FD or DF. So AC over DF. And if we do the ratio there, AC is 16, DF is 12. Well, simplifying our fraction, these are both divisible by 4. So we have 4 over 3. So far, so good. Now we just have to check the last one. So the last ratio is going to be BC right here, 24, and BC and EF. Well, 24 over 18, if we divide that by 6, it reduces to 4 over 3 as well. So all of the corresponding angles are congruent. All of the corresponding sides are proportional. So these two triangles are similar. We can write our similarity statement and similarity ratio. The ratio is just the ratio of the sides. So the similarity ratio is 4 over 3. And then for the similarity statement, that's where you just say like triangle ABC, A, B, C, and then I'm going to go in the same order, similar to, and then it's D, E, F, so that my congruent angles are in the same spot in the statement. You can try the try now on your own if you would like. Pause the video now, and when you hit play again, I'll have the answer posted. Please pause. Okay, here is your answer. So they're similar because the corresponding angles are congruent and the corresponding sides are proportional. The ratio is 5/2. And then for the similarity statement, there's a lot of different ways that you can write it. The key is that the L and the P have to be in the same spot. So notice how I have L first, P first, and because they're congruent and corresponding parts have to be in the same position. M and N have to be in the same position, so I put M here and N there. And then J and S have to be in the same position. So J, S. Now you could reorder them differently as long as the corresponding angles are in the same positions. Moving on to example 3, we're going to apply some ratios in similar polygons. So this time it's telling us that triangle ABC is similar to triangle DEF, and we want to find the length of side EF. So I'm just going to put an X right there in my picture, and let's see what EF matches with in the other triangle. Well, EF matches with BC. All right, next up, I just need another pair of matching sides. So I'm going to pick this 12 right here, side AB, and AB matches with DE. So when you set up your proportion, you have a lot of different ways that you can do it. You just need to make sure that you're matching up like parts. So the ratio I'm going to use is BC over EF. So that's like my 15 over X. So I'm going left to right. 15 over X equals, and then it's AB. And then I need my second match. Remember, I was going from left to right. So AB is going to go on top. DE is going to go on the bottom. And then if we look at our picture, AB is 12, DE is 19.2. Now let's solve that with a cross product. 15 multiplied by 19.2 is going to equal X times 12. Calculate that 15 times 19.2, and that is equal to 288. And then if we divide by 12, 288 divided by 12 is 24. So the missing side X is 24. So I guess the question asks for EF. So EF equals 24. Now, another situation I could give you is instead of giving you matching sides, I could give you just one triangle and the similarity ratio. So this time, triangle ACB is similar to triangle XYZ, and the similarity ratio of triangle ACB to triangle XYZ is 2/3. So let's start by writing out that similarity ratio, 2/3. And the 2 on the top corresponds with triangle ACB, and the 3 corresponds with triangle XYZ. Now, the question is asking us to find the length of XZ. So XZ is this side right here. I'm going to put an N there. I don't want to use X because it's already got an X there. So XZ is right there. Now let's look and see what XZ matches with. XZ matches with, well, XZ matches with AB. And AB, you can see in the picture, is 15. So now we have a proportion, and we can solve that with cross products. 2 times n, 2n. 3 times 15 is 45. Divide by 2, and you will get 22.5. So the missing side, side XZ, is equal to 22.5. All right, let's do one more of this type. This time I have a rectangle that is 3.2 centimeters wide. So 3.2 centimeters, that's the width, and 8 centimeters long. A similar rectangle is 5 centimeters long. So I just have to make sure that I match them up. That's why I'm adding the labels. So 5 centimeters is the length. So the length has to match up with the length. So they're across from each other. And then the width has to match up with the other width. So what's the width of the second rectangle? Well, I'll just call that x. And once again, we have a proportion, and we can solve that now with a cross product. 3.2 multiplied by 5 equals 8 multiplied by x. So 16 equals 8x. Quick divide by 8 gives us 2. So the width of the second rectangle is 2. You should include a unit. Everything's in centimeters, so the x is going to be in centimeters as well. The last example here is a real-world application relating to scale models. And you're going to see models a lot outside of class. So for example, someday you might want to buy a bookshelf, and the directions on the paper that comes with the bookshelf is going to be a scale model of the actual bookshelf that you are building. So the model is similar to the real thing. So in this case, a rail boxcar can be used to transport auto parts. The model of the boxcar below is similar to the actual boxcar. So the length of the boxcar is 7 inches in the model, and the width is 2 inches. So this is my model. Well, if the length of the actual boxcar is 50 feet, so maybe it would be nice even just to draw a picture. So the real boxcar is 50 feet long. What is its width? I don't know. Well, when you write your proportion, there's a lot of different ways that you can do it as long as you match up like parts with like parts. So for example, you could do like the length of the model divided by the length of the actual boxcar. So like this and this would match because this is my actual boxcar. And then we'd have to do same pattern, width of the model. So the model is on top, and then the width of the actual on the bottom. So it does kind of help if you at least like label them a little bit. So now let's put our numbers into our proportion. Length of the model is 7 inches. Length of the actual boxcar is 50 feet. And that's going to be equal to the width of the model, which we can see is 2 inches, divided by this, which is something in feet. Now, even though the units are different, that is totally fine as long as the units are lined up. So notice how I have the inches at the top of my fraction because the top of my fraction is like all dealing with the model. And then I have the feet, the bottom of my fraction, because that's dealing with the actual boxcar, which is much bigger in feet. So now we can still do our cross product. We'd have 7 times x equals 50 times 2. That's 7x equals 100. And if we divide by 7, this doesn't divide evenly, so we're going to have to round. 100 divided by 7 is 14.285. We'll round to the nearest tenth of a foot, which is 1 decimal position. 8 rounds up, so we'll change it to 14.3. So the actual boxcar is 14.3 feet wide. For the try now, there's a lot of different ways you can set up your proportion, just as long as you match up like parts. So for example, length here matches with length there. I want to find the length of the model. So the 5 matches with the x. So 5 meters matches with x centimeters. And then the 1.8 meters, The width of the thing matches with 6.3 centimeters. Notice how my units line up. So I have meter, meter, centimeter, centimeter. And I went the same direction both times. So 5 over x, 5 is the top, x is the bottom, 1.8, 6.3, top, bottom. Now we can just go ahead and do a cross product. 5 times 6.3 equals x times 1.8. Take your calculator and you will get 31.5 equals 1.8x, divide by 1.8, and that ends up being 17.5. And that's already rounded to the nearest tenth of a centimeter, so we don't have to round. Just add that label, and there we go. Now, I realize this video is getting kind of long, but I just wanted to show you another way that we could do this. So there's more than one way to write a proportion as long as you follow the same pattern so that like parts match up. So in the things to remember box, I matched up like the 1.8 and the 5. So I went like left to right. So 1.8 over 5 equals, and then 6.3 over x. And what you'll find is that it's actually the exact same cross product. You get the exact same answer. So there's a lot of different ways you can do your proportion, just as long as you follow the same pattern each time and that your like units line up either horizontally, like they did here, meter, meter, centimeter, centimeter, or vertically, like they do here, meter, meter, centimeter, centimeter. That's all for 7.2. Thanks for watching. Bye.